Hey guys, so I thought we'd keep it pretty simple coming back off of semester one, being done with everything. We're going to basically talk about the life zones in two different places in lakes and in oceans. There are some similarities that you'll see, but basically this is going to be pretty short and sweet. So this first picture that I have up here for you is just a division of lakes. So this is your lake here, and the littoral zone. Excuse me. The littoral zone will be the area near shore that has enough light penetration for plants to grow. So that's the littoral zone, which is basically the shore or the shelf of the lake up to the shore. Then the limnetic zone is just open water. And usually they'll call the limnetic zone kind of this upper half that receives light, and then the lower half where excuse me, where light doesn't penetrate as far will be called the profundal zone, which I'll show you a picture that has that. There's so many different I don't know, divisions that different people use, so I'll kind of show you what we plan to use. So notice there's going to be the littoral zone this is a side view cutaway. So if you surrounded a whole lake, that littoral zone would extend out to a depth where it can support plant life growth. And then the limnetic zone is basically open water over the area that doesn't support enough light to support plant growth. Sorry. And then the benthic zone is going to be the bottom, so it actually extends through the littoral zone. Can even extend into the limnetic zone depending on how deep the water is there, and then the profundal zone definitely has a benthos. If we look at some other divisions, just to kind of give you some different stuff. So this one again shows your littoral zone on the outsides, the shore areas. And then your limnetic zone is the open water zone that is above the profundal zone. The profundal zone, again, if I didn't say it, is the area that gets very little light. You can't support any plant growth down there. Typically it's called low in oxygen, those types of things. Sorry. Then the benthic zone is, like I said, the bottom, so it's the actual substrate that is the bottom of the lake, and it extends from the littoral zone all the way through the entire lake, including all the zones. So that should kind of be the lake zones. Some general features of these zones that you want to be aware of. Obviously it's going to be warmer at the top because that's where we have light penetration. That's usually where oxygen is most rich as well, because remember, oxygen gets into the water through the surface interaction with air. Then as we travel down, it's going to be colder. Temperature is going to get a little bit lower usually because of light penetration. That means the heat can't get deeper into the column either. And then oxygen typically starts to deplete, especially as you enter the profundal zone. So again, the big things are going to be light decreases, temperature decreases, and then really oxygen decreases. But there are some ways through lake turnover and things like that we can increase the oxygen amounts down here that we talked about last semester. So there is a thermocline that also exists here. You have higher temperatures here, and then as we go through the column of the lake, temperatures start to lower until you get to the bottom where they are typically at their lowest. That thermocline, remember, sets up stratification, which resists mixing events when the wind blows. So that would be pretty much your lakes. If I switched over to ocean zones. So this is ocean zones. There is a lot here. I would suggest writing this down or finding this picture. If you type in a search for open ocean zones, the first one that comes up is probably this, or it's pretty close to that. I think it's the image they also use on Wikipedia if you look at ocean zones on Wikipedia. But there's a couple things to note. This solid line right here is going to be the surface of the ocean. So we have a horizontal division, and then we have a vertical division of the ocean. And there's a couple things that you need to note. Pardon me. All right, first, all of this open water zones from the shore, basically the low tide mark, out into open ocean is called the pelagic zone. And then the littoral zone is basically the tidal zone. So it's the area of shore that is exposed during low tides and then is covered during high tides. So sometimes you'll see that called the intertidal zone or the tidal zone, different things for it. But notice we're going to call it the littoral zone, which kind of gives it the same connotation that we used for lakes. Then if we look at the pelagic zone, it's actually going to be separated into two zones, the neritic zone and the oceanic zone. The neritic zone extends to the the continental shelf, basically. So it's basically shallow water, relatively speaking. It can get up to about 300 meters, 400 meters deep, but it's relatively shallow compared to the entire ocean. And then oceanic is just going to be open ocean water, and really I probably won't focus too much on neritic and oceanic as much as the vertical zones here. So notice the top zone, which is also called the photic zone. Photic means that it has light. So the upper level of the ocean is going to be called the epipelagic zone. That extends to about 200 meters. Meters, remember, are bigger than a yard, so about 3.5 feet. So when we're saying 200 meters, we're talking about several football fields deep. So this is pretty deep water. But light doesn't penetrate too much past the epipelagic zone. Epi means surface, by the way. Pelagic is the zones that we're talking about. So this is the surface open ocean zone. So epipelagic extends to 200 meters. It has light. And then once we go below 200 meters, we start losing light fast. The mesopelagic zone barely has any light. It goes down to 700 meters, 700 to 1,000 meters. And then notice the temperature is also decreasing. The bathypelagic goes down to 2,000 to 4,000 meters. So again, really deep. And then the abyssal pelagic goes down to 6,000 meters. And then the hadal pelagic is basically just the Marianas Trench, if you've ever heard of that. It's look it up. It's basically where James Cameron, the guy that did the Blue People movie, he also tried to dive the deepest dive to the deepest known spot in the ocean. It's called Challenger Deep. He actually did that a few years ago. The amount of money that is needed to accomplish such a feat because of all the pressure involved is pretty extraordinary. He obviously has that amount of money and was able to accomplish that feat. Last time anybody got close was in the 1950s, and then he went back and actually touched bottom there with his own little submersible that he built. So look that up, Challenger Deep, if you want. Sorry. And then notice the other thing we have in common with lakes is the benthic zone. So the benthic zone will extend all the way from the littoral zone through mesopelagic, bathypelagic, abyssopelagic, hadopelagic zones. It's basically the mud, the substrate, the surface of the bottom of each of those zones. Just like the lake zone, same things happen here for the most part. Most of your light is up here, and then these aphotic zones. A means not having or lacking, so aphotic means missing light. Photo means light. Ic is pertaining to, so pertaining to no light is what that means. And then photic means that it has light. So in the top layers of the ocean, or in the top layer of the ocean, we have light. Then as we descend deeper and deeper, there's less and less light, at least from the sun. Same thing with temperature. As we descend deeper, temperature gets less and less. And then oxygen will do the same thing for the most part. There are some, when we talked about deep water currents, upwellings, downwellings can bring oxygen down to those levels, but for the most part, Oxygen is going to need to become less, temperatures less, lights less. And really I guess the other thing is wave action. So wave action becomes less. Up here, the wind can affect and create waves, which we didn't get into too much, but we talked about currents and things like that. The deeper you get, the less you feel those waves, so the calmer it gets. That also happens in lakes. So really, for now, that's it. I just wanted to set up these life zones for you so you kind of had an idea of where we're at in a lake, and then next time we'll come in and we'll start adding some organism cities and look at some things that happen in these zones. So that's it for now. If you have these pictures, you should be ready for the quiz that's on there. So go ahead and take care of that when you're ready.